Today's lesson is 5-7. What you're doing today is interpreting two-way tables. Yesterday, we created them. We found our percentages, we did our tally marks, and we created the two-way table. Today, all that you are doing is answering questions from the two-way tables. Now, what's different from yesterday's questions compared to today's, in yesterday's questions, we were always looking at the whole entire table to make your percentages and things like that. Today, you're really focusing in on a lot of times just one column going up and down or one row going side to side. So you're going to see in these examples that we do that you're only looking at part of the table today, not the whole entire thing every time. So let's take a look at the first one. First of all, again, read carefully so that you know which total to use as your denominator. Remember, when you make a fraction, it is the part over the total. So you might have like 4 out of 20 or something like that. Remember that you always do the top number divided by the bottom number. You're going to get a decimal, and then you have to move the decimal point over 2 places to the right. So let's take a look at this first one. Again, you're only looking at one row or one column today. So it says a survey of students in a class explored the relationship between gender and vegetarianism. So they were asked, are you a boy or a girl? And are you a vegetarian or not a vegetarian? So take a look at the question that's being asked. If a girl is chosen at random, what is the probability that she is a vegetarian? In this question, does it say anything about boys? No, it doesn't say anything about boys at all. So we're not looking at this row at all, because in this question, it only asks about the girls. Well, if we're not looking at the boys, we're not looking at the total row either, because if we get rid of the boys, it changes all those totals. The only thing that we are looking at in this question is the girls row going across. So if a girl is chosen at random, what is the probability that she is a vegetarian? There are 6 girl vegetarians out of how many girls? Because we're only looking at the girls out of 15. So you're going to put your fraction as 6 over 15. Remember, to make your fraction into a percent, you have to do top divided by bottom. So 6 divided by 15, when you type that into your calculator, you get 0.4. Remember, to make it into a percent, you then either have to multiply by 100 or move the decimal point 2 places to the right. So if we move the decimal point 2 places to the right, it ends up there. We put a 0 here. So this is really 40%, which is choice C. Take a look at the next one. We're looking at that same two-way table. This time it says, if a boy is chosen at random, what is the probability that he is not a vegetarian? In this question, are we talking about the girls at all? No. So we're not talking about that row. We're not talking about that row. We're just talking about the boys. So if a boy is chosen at random, what is the probability that he is not a vegetarian? Well, not a vegetarian is 12 boys out of a total of 15 boys. So 12 out of 15, top divided by bottom. On your calculator, you would get 0.8, and then move your decimal point 2 places to the right to make it into a percent. So this is going to be 80%, which is choice A. Take a look at the next one. This is a very, very common question on your state test. Which is a reasonable conclusion to draw from this data? Now, reasonable conclusion means that it is a true statement. So 3 of these are false and 1 of them are true. We're looking for the one that is true. When you go to do this, the only way to do this is to just do a process of elimination. You got to try it, see if it works, see if it's true or not. If it's not, move on to the next one and see if that one is. So let's start with A. There are more vegetarians in the class than non-vegetarians. So total vegetarians, there are 9. Total non-vegetarians, there are 21. There are more vegetarians in the class than not. Is that true? Is 9 bigger than 21? No, it's not. So A is not true. Take a look at B. Among the boys. So we're only looking at the boys. Among the boys, there are more vegetarians than not. 3 compared to 12. Is there more vegetarians than not? No, 3 isn't bigger than 12, so that is not true either. Letter C says among the girls. So now we're only looking at the girls. Among the girls, there are more vegetarians than not. 6 compared to 9. Is that true? No, it's not. Well, that leaves only D as our answer, but let's take a look at how that's true. The probability that a girl chosen from the class is a vegetarian is greater than the probability that a boy is a vegetarian. Well, are there more girl vegetarians than boys? Yes, 6 versus 3. So that one has to be true. Take a look at the next one. In this next one, it says Megan surveyed the 8th grade to find which school activities they attended last weekend. Notice that there was a basketball game and there was a school play. Some people, 55 people, went to both of those. 63 people went to the basketball game, but not the school play. 88 people went to the school play, but not the basketball game. And then 15 kids didn't go to either one. They didn't go to the basketball game, didn't go to the school play. So this one says, what is the relative frequency? Remember, relative frequency means your percent of students that attended the basketball game and the school play. Basketball game and school play, we're looking right there at 55, to the total number of students that attended the school play. The total number of students that attended the school play is 143. So they want 55 out of 143 because that's the number of students that went to both compared to the number of students that attended the school play. So 55 out of 143, top divided by bottom. When you do top divided by bottom, you get 0.38. Again, move your decimal point 2 places to the right. So this is 38%, which would be choice B. Take a look at the next one. Which of the following is a valid conclusion? Valid conclusion means a true statement about the data. So again, we're still looking at the basketball game and school play stuff. So when we take a look at this, take a look. The only way to do it is process of elimination. So let's take a look at A. Of the students that attended the basketball game. So out of the students that attended the basketball game, that's what I'm circling right now. More than half of them also attended the school play. Is 55 out of 118 more than half? Well, if we do 55 out of 118, let's see what percent we're going to get. If we do 55 out of 118, you get a decimal, a big long decimal that is 0.46610, blah, 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 blah. So if we move the decimal point over 2 places, this is really like 46.6%. Is 46.6% more than half? No. 50% is half. So 46% would be less than half. So it's not choice A. Let's take a look at choice B. More than half of the students that were surveyed. So we're looking at all of the students that are surveyed, attended the school play and did not attend the basketball game. Attended the school play, did not attend the basketball game is 88. So is 88 out of 221 more than half? Well, when you do 88 divided by 221, you get that that's roughly about 39.8%. Is that more than half? No, because 50% is more than half. 39 would be less than half. Let's take a look at letter C. Students that attended the school play were more likely to not attend the basketball game. Students that attended the school play, so what I'm circling here in blue, were more likely to attend we're more likely to not attend the basketball game. Well, out of what I circled in blue, did more people not go to the basketball game or go to the basketball game? Well, 88 is higher than 55, so they're more likely not to go to the basketball game. That one is the one that is true. Let's just take a look at D. D is going to be wrong, but let's take a look at it anyway. More students did not attend either event. Did not attend either event would be 15. Did most students do that? No, that's not true. All right. So that's why it's choice C. Let's take a look at this last question. In this last question, take a look at your two-way table for a minute before we even get started. When you take a look at this two-way table, what is the two-way table missing? What is the two-way table missing? Well, the two-way table, the two-way table is missing the totals. Sometimes they will try and trick you by not putting the totals. There's one like that on your homework today that doesn't have the totals. So if it doesn't have the totals, I would find the totals first. 4 plus 1 is 5 going down. 2 plus 3 is 5 going down. 4 plus 2 is 6 going across. 1 plus 3 is 4 going across. So how many total people were in the survey? 5 plus 5, 6 plus 4. Both ways that you do it, that means there were 10 total people in the survey. So now the two-way table shows the number of Sasha's soccer teammates that are in her math class and her English class. How many total teammates does she have? Well, total teammates, that's going to be this number right here, which is 10, because there are 10 total people in the survey. What is the relative frequency? So what is the percent of teammates that are in both of her classes to all of her teammates? So in her English class and in her math class, there are 4 of her teammates compared to the total number, which is 10. So 4 out of 10, top divided by bottom, you get 0.4. Move your decimal point over 2 places, you get 40%. Letter C. Of the teammates in her math class, so we're just looking at her math class. Of the teammates in her math class, which percentage is greater? The percentage of students that are in her English class or not in her English class? So are there more students in her English class or not? Well, it would be in her English class because we're looking at 4 compared to 1. So those are the types of questions that you're going to have today. Again, sometimes you're just looking at the column. Sometimes you're just looking at the row. Sometimes you're looking at the whole entire thing.